So hi, I'm Hendrik. I'm going to talk about different way of architecturing your front-end applications. Just out of curiosity, how many people deal with web apps or front-end technologies? Okay, quite a lot. Cool. That's good. So as a background, I was a software engineer at Teleport for 2 years. I worked on almost all of the front-end apps there. And then since we were acquired this spring, I've been a front-end developer at MoGuides. I've been working on the employee experience there. Over the years, we've gone through various iterations of our front-end stack. We started out with Reactive. Has anybody used Reactive or remembers Reactive? Okay, so one person. It's an interesting framework. Got started around the same time as React, but never was as popular. Also used virtual DOM for doing DOM updates. But as our application grew bigger, it kind of got out of hand and was pretty hard to maintain. So at some point, we also noticed that the React community was much more vibrant. So we switched to React. And for some reason, things started going way smoother. And after a few other iterations, we've now landed on React, style components, and Typescript. But looking back at the whole journey, I think the biggest lesson is that it's not so important what kind of framework you use to build your applications, but it's more the way you structure them. So React was very good for us, but I think it's mostly because it happened to encourage this component-based architecture. And so far, we've found it to be the best approach to building complex and most of all scalable front-end applications. I'm sure there are more, but and this is definitely not the one true way of building front ends, but it's been very useful to us. And I think this kind of pattern is not limited to React, but similar concepts are in Vue, Angular, and now with web components in web standards. So to start at the very basics, like what is a component? I think Lego blocks are very good examples of what a component is. Like it's a small building block with a well-defined purpose and a clear interface. So it means you know what the component does and how you should use it in an application. And typically it handles some kind of logic and renders stuff. Stuff can be HTML or other components. This is still pretty abstract, so we can walk through how a simplified version of a component we actually use works. So this is a select component, which basically renders a select box with some options. It has a pretty simple interface. You have a value, you have an onChange function that basically tells the parent component to update the value, and you have the options that are rendered here. If we take a look at inside this select component, this is pretty much all that it does. It renders these options and another component called styled select element. So it does one simple thing and passes everything else onto another component. And this styled select component also does pretty much one simple thing, which is render a select and attach a class, which ties back to the style element there. And the select itself renders the HTML element and attaches these React values and event callbacks. So to recap, select renders the options, styled select the styling, and select the actual HTML element. And this is what we get in the end, which is slightly more complex than the simple select interface we had here. Now, if we take a step back, there's a pattern emerging here. So essentially, we're building more complex components out of simpler ones. We can do it layer by layer, and each layer handles a different concern. So we can use the same select component we built and make it into a date select that just puts 3 selects here and allows us to select the date. And this is pretty much what the interface there looks like. And this makes intuitive sense for shared components. We want to have a library of small bits and pieces we use everywhere in our app to ensure consistency and so on. But why stop at shared components? So what if the entire app is components all the way down? And that basically is the essence of the component-based architecture. So you take your big app and you slice it into small logical components. Each component handles some of the functionality and hands off the rest onto other building blocks. And the components are encapsulated with well-defined interfaces. So basically, to the parent component, the building blocks are like small black boxes that only get interacted with by the interfaces. So this sounds interesting, but why should you actually use that? There's another interesting property that kind of emerges from this design is that complexity doesn't change too much as you go higher in your application. So, for example, this more complex select-based component doesn't have an interface that is it's not more complex than select itself. If we take a more involved form here, which contains 5 different inputs, this is also basically a very simple interface. So there's a value, there's a callback to update the value, and some parameters to set the limits and currency. And this tends to hold true on almost all levels of your application. So basically, this actually is an aspect that isn't talked about too much. Like, I think the biggest value of a component-based approach is that it reduces cognitive load. It helps us break huge applications that are complex into manageable chunks. Basically, it helps us with the problem that we're all basically naked apes mashing buttons, and we have fundamental limitations on how much we can understand at one point. So small components are way easier to understand and reason about. And another useful thing is that the same pattern of building stuff, so decomposing it into components, applies from the smallest element to the highest levels of your app. There are other benefits as well that stem from the fact that the components are simple and pretty small. So they're harder to screw up than big things. They're easier to test, because components usually do one fairly simple thing. Easier to refactor, and as I mentioned before, they're easier to understand. So you can basically hold the entire component in your mind at once. And it's also pretty useful for code mobility. So components with clear interfaces can be reshuffled pretty easily. So this is both within a single project or between similarly set up projects. There's a caveat here that if your stack evolves quickly, your different projects can get out of sync. So one uses, for example, SAS style sheets, the other one style components. And we've had a lot of problems with various slightly incompatible sets of TypeScript settings. But within like a reasonable stack, it's pretty easy to move components into other places. The consequences are that you can make changes to your app pretty quickly, and you can build new things with existing pieces. And this has direct consequences to delivering actual business value. So an example from Teleport is that we built these city pages that contained a bunch of different widgets that surface data to our users. And one day someone bounced this idea in a chat, like what if we built a tool for recruiters and HR people to send to the candidates who are moving to new cities. They might not want to visit the full Teleport site. Also, they might not, the HR people might not want to show them the salary widget, for example, for various reasons. So within like an hour, we actually built from the components we already had this customizable report builder. So everything you see here was basically the same code that ran on the city page, but just put together in a different way. So the Lego analogy is pretty good, pretty adequate. Yeah, this was the overall concept of a component-based architecture, and there are a few things we've found especially useful on the way. So how you organize components is also important. This kind of layout that we've finally gotten to. So it's basically single file components with a main component and styled components, which are just the small styled selects and stuff like that only attach styles. And there are co-located assets and tests. So basically there's a small folder that you can drag between projects, and it should contain everything you need for that component. Another very valuable asset has been Typescript. So it helps describe and actually enforce component interfaces. So and also it's kind of documenting the code as well. So this is a interface for the props for the select component. And if you use it wrong, like forget the prop or put a number where it shouldn't go, IDE will tell you. And catches errors very quickly. Also helps in refactoring. We used to have a lot of bugs where an API changed, for example. We had to manually find all the places where that API was used. And sometimes when you pass data through various layers and components, it can get lost. So TypeScript has been very useful. Another thing that we use a lot and have started using recently is styled components. And this takes every component should have a purpose principle to the tiniest basic blocks. This is a way to add styling to various HTML elements. It's very convenient, very quick, but most importantly, you kind of have to think about why stuff is there, because you have to give names to your styled components. So, not too proud of it, but there used to be times where I added like 5 divs inside each other and it didn't blink. But now when I'm naming the 5th component something wrapper, I kind of start to think like maybe is there a better way to do this? So you have to assign like meaning to all the components you're using. Something that's kind of funky is React Router. So this, the latest version of that kind of turns routes into components as well. So you used to have this routes file where all your views and stuff was routed. And now you can use these components that you can put pretty much anywhere in the app. So you can have this base level app component that routes to views, and that's it. And the views do internal routing within themselves with another bunch of React components. And you can do all kinds of levels of hierarchy like that. It's the same basic principle of handling one simple thing and then handing the rest of to child components. And the last thing is distributed data fetching. This is actually an in-house framework we built. But since we used we ran on a microservice architecture teleport in these days as well, and we had a bunch of different APIs, and a lot of the components, like the widgets, pull data from very different sources. So we found it to be much easier to co-locate data fetching with widgets. So all of the widgets define the data they need, and they get fetched by the component. So instead of managing data centrally, kind of have a mechanism centrally to fetch data, and widgets say just what kind of data they need. And this solves the overfetching problem as well. So we don't want to fetch all of the data we might ever need in the application at once, just the bits we need. And also that data requirements are defined where it's actually used. And that's pretty much it. Are there any questions or suggestions? Yeah.
The components you're building, once you have a hierarchy of those, there are times when you need to send like commands or messages to the, let's say, child components, and there is not like a very intuitive way of doing that. Or what's your experience with that? I mean, you can declaratively specify the attributes of that, but sometimes you want to like send some messages or commands which they need to react something, like change its internal state or something. Have you any thoughts on that?
Do you mean through a big layer of other?
You have like a, I don't know, maybe like the example with the date selector.
Yeah.
So you want to, well, an easy example is that if you want to change the date, then you change the values of the attributes basically.
Yeah.
But let's assume you want to do something more tricky, like highlight a range in the displayed calendar or something. So, and maybe it has several of these options, like it has different ways of doing things. So what I've experienced myself, not with Rect, but with a different framework, but I think the idea is the same, is that while it is relatively easy to declaratively specify the data attributes, once you want to, like more richer communication with the component, that kind of, there isn't an easy solution for that.
So there's Redux for, we store, for example, the data that components fetch, we store in Redux. That's shared across all the components. So I think
it's basically like, could a component have an API, like expose an API, and it's besides the attributes that you can declare. That's like the fields you can change, but besides fields, you would want to have some methods, like do this or do that, and that is a little bit tricky, I think, for web components with any of those frameworks.
Okay, fair enough. So I think there's still a lot you can do with properties or the attributes you set.
You can work around things with that, but what I'm wondering, have you any like experience or thoughts around that?
Not really. So a lot of what we do is a teleport anyway was displaying data. So it was very easy to write components that were basically a function of their properties. And if there was some kind of functionality in the components, you had these handler methods that you pass on to the component, and then when something happens, it notifies the parents, and that triggers the data flow again. But I know there are various frameworks for that, like Redux, for example. Components can dispatch events, or there's Redux Sagas as well. So there are, I think, a bunch of ways you can do that. But yeah, I don't have a specific answer, sorry.
The question about these changes of frameworks that you showed in the beginning, when you change it from the SAS and this to the styled components, was it hard to kind of move from this way? Is it difficult to update your
No,
frameworks to the styled components? I mean,
not too difficult. It was slightly annoying because we had to name all the HTML elements we used and move the bits and pieces from a style sheet into different locations. But yeah, it just actually for the switch to styled components, we mostly just started a new project with it.
again,
Then we had some components that we had to bring over and did them one by one. So there wasn't actually too much conversion going on.
so it's better to start from the beginning again.
Oh yeah, definitely.
You mentioned the reuse by copying the component to different projects. Is it like an ordinary way how you do it, or is like a shared component library which you include to every project, or which way you do it?
So for the switch, for example, to the latest the style components thing, we actually copied them over. But we used to have a UI kit library that was published on a private repository on NPM. Same for APIs. So we had like 4 or 5 front-end applications. They all shared the same UI components and the same API methods. So I think that was we tried different things, but that in the end was the easiest and cost us the least amount of sleep. It got also pretty complicated with TypeScript typings for a while, but these days it's pretty nice.
So you would suggest doing that
Yeah,
by copy? Okay.
like a shared package or something.
Okay.
And it's a lot easier if you're using some kind of typing overlay like TypeScript or Flow.
And you answered for the first question with Redux Saga and how it's better than just using this kind of new thing, you know, using these generated functions. Does it help much?
We haven't used it
Haven't
too
used
much.
it,
You can do interesting stuff with it, but it's for our use it's too complicated. So we don't even use regular Redux too much now. It's kind of a backend for the data fetching framework, but that's pretty much it.
I think that's it with the questions. Thank you so much.
Thank you.